Welcome to another GCBASIC demonstration for the PIC18xxQ24. This is part 4, sequence the LEDs. So, where are we? We are working on a 18xQ24 and we're working through a series of videos to get to show you all the capabilities of the compiler. Like and subscribe, let it run all the way through. Those metrics are very important to me and to YouTube. So where are we? Number 4 of 20. So we've installed the hardware, got the IDE working, done some work with some LEDs. Last video, we left it like this. I'll just look at the desk cam. We left it like this, where we can rotate the potentiometer and 4 LEDs light up to represent the value of the ADC, and we used a particular command there. So what we're going to do today is sequence these, create a sequence, which is quite useful because it introduces many different techniques. So I am assuming you've installed the software, you've got your programmer working, you've got a Q24 attached. By the way, this program, you just have to change the chip at the top and it will work on most microcontrollers. You've got the 4 LEDs and you have a pot attached, just like I showed you. So what have I got? I've got RA0, I've got my pot attached, and I've got 4 LEDs attached to RB0 to 3. And you can change those about. They're not hard coded. You can just go into the source code and change them as you see fit. What does it look like in terms of a diagram? That prototype board is powered at 5 volts. PIC18xxQ24 is attached. I've got an LED and some resistors. And this is the little diagram I use to show how to document it. I've got on port A, on port A0, my potentiometer, and on port B, where's my pen gone? On port B, sorry about that, I've got these 4 LEDs. And we'll come on to VDDIO2 later on. So, we're going to build upon the previous, and we're going to introduce lots of concepts very quickly. So, one is time. GCBASIC calculates delays for you in terms of hours, minutes, seconds, 10 milliseconds, 10 microseconds, and microseconds. It does all that calculation for you within the constraints of that frequency selected. So if you choose 64 megahertz, it will do all the calc. If you say 1 millisecond, it will be 1 millisecond. If it's 4 megahertz chip frequency, it will do that for you. So it's an adjustable thing in the back end, in the compiler, and you just use it by saying wait the time and a unit. Wait 1 millisecond. Wait 1 second. Wait 1 hour. And the program will do that for you. Time. So what we're going to do is we're going to change this. I'll just bring my pen up. We're going to play with this variable here. That's what we're going to do, play with that, the time. So we're going to complete the program and we're going to use the ADC. And so what happens is the program is going to initialize the chip. We're going to create some variables, more specifically the ADC results. We're going to read that ADC and we're going to use a larger range, read AD10, which is a range of 0 to 1023. So read AD10 is a larger range, 10 bits. We're going to wait for a period of time based upon the ADC value. Set the LEDs and do it all again. And it looks like this in terms of a flowchart. And you need this. Waits are quite useful in your program, so it's a good command to know. So yeah, GCBASIC will initialize the chip. We're going to set the value of the. We're going to set the first LED on. Read the ADC. Wait for a delay based upon that. Rotate the LEDs. That means shift them along. And then, did it overflow? Did the last operation overflow to something? I'll explain what the something is. If it didn't, it knows it hasn't got to the end and it will just do it again. And eventually on the 4th iteration, it will set the first LED and then it will go back. Quite simple. So how does it know? It's called carry, rotate with carry. And it does this. It moves along the LEDs, 1, 2, 3, like that. And sequences through these. It sets it to 1, sets it to 1, sets it to 1, sets it to 1, then to 1, and then it does something. Let me walk you through it. First time, we're going to set an LED. We're going to rotate into this position here, the first position. Then we're going to use the rotate command and just shift the values across. So we can shift them across in the file register. Then we're going to shift them again. Then we're going to shift them again. So we're constantly moving to make sure that things are moving along so it looks like a pseudo rotate. And finally, it's going to like fall off the end, and it falls off the end into what's called the carry register, which is the SReg bit 0. But what it does, it sets the carry, and at that point we can test for that, and we can restart the process and go again and again and again forever, because we can keep testing for the carry. How do we test for the carry? How do we carry out that did it overflow condition? Well, in GCBASIC you simply say C. If C equals 1, or some other test condition that you can come up with, do something. It's really very, very simple. If C equals 1, and we know it overflowed into the register, the S register, SReg, bit 0 was set, we just know it's overflowed. So once we've done that, we can then do some other stuff, and we'll look at a thing called scale, and scale lets us transform numbers from one value to another range. So you can have a range of 0 to 10, and you can make it a bigger range. Obviously, you've got constraints, but it's very useful. And we'll look at using scale as well. So we've increased a new command, read AD10. We've got weight, scale, and overflow using the C register. Quite a lot in this one demonstration. It's quite useful. So what we're going to do is go straight into the workshop and see what we got. Recap, desk cam, that's where we left it. Back into desk. I've started up GC code. It's sitting there where we left it yesterday. I am now going to close that down. All gone. So I've got the folder that I'm working on. It's the Q24 demonstration folder, and I've opened it up. I can open that up by open up the Explorer or Control B. You choose. I've got many files in here. And remember, I will keep doing this. Click on here, Control F, GCB, and it will filter, because you can select a little filter at the top, and it will just filter on the source files. And now if I take variable rotate with the LEDs, file 60, and open it up, then Control B will shut down that side window. Great, let's go, let's walk the code. Remember, green is comments, not interested in that today. I'm going to talk you through it. The first part, I'll zoom in, is this, is specification of the chip and the option explicit. I said earlier on that weight is dependent upon the frequency. Well, you would set the frequency like this. You would say 64 megahertz. You might say 32 megahertz. You might say 8 megahertz. And I'll cover where you can find the details of that in another video. Option explicit, define all my variables. We've seen this before. Create a constant. To create a constant called LED0, use the hash define. And it will create a constant, and that will refer to port B.0 whenever we use that constant. I create another constant for all the ports called LED port. So if you want to shuffle things around, just make sure you change these constants if you change things around. Set the LEDs to out. All 4 of the constants are set to out because they are output ports. Constant defines the potentiometer on port A. It's just for reference. It's not actually needed. And that's it. So we set it up, selected the chip, set up some constants, and set them all to out. Fantastic. Let's get into the main program, into the meat. Well, we set up a variable last time called ADC val and changed it to a word because I need a greater range. I need the range, a much bigger range than what a byte can hold. So I say a word. I've got a variable called LED state, and I want that to be a byte. So a range of 0 to 255. Then I've set that variable called LED port state to B1000001. Now 1 and 4 zeros. So it looks like it's going to set the wrong LED on, but it's not, because the first thing we're going to do is rotate, and that first rotate takes us into a good position. I just want to, you can have that any position, start any way you like. I just chose that one. Okay. All right. Anything in red, ignore for the moment. Here, read AD10 is the function. It's a function, and it returns a value of 0 to 123 when it reads this specific ADC. And we got that in the previous video from the data sheet. They're not always the same, but always check the name of that on the data sheet. And then I'm saying here, wait so many milliseconds. And where's it coming from? It's going to be the returned value from here. So that will be in the range of 0 to 1023. So wait 0 milliseconds. Oh, that sounds like nothing to me. So we'll have to fix that to 1023 milliseconds. And then the carry stuff. Because we want to test the carry, we need to know it's in a good state before we use it. So we set the C, or carry flag, and it's always C in GCBASIC. No matter what the microcontroller is, it's always C. It makes it code portable. C equals 0. Clear the register. Clear that carry register, that little carry bit. Rotate the LED port state to the right. So shift everything to the right. Move the LEDs to the right. And if the carry is equal to 1, then set the LED port state back, set one particular bit in that variable to 1. So it will look like it's rotating around. And then set the port. And how do I set the port? This is my target port, port B in this case. Take this fancy variable we've been working with and mask it. Create a mask. Only handle the 4 lower bits, these 4 bits, and that's where our LEDs are. So it's creating a mask of B15. It's actually decimal 15, which is binary 1111. LED port and a mask of 1111, which means strip off, just ignore everything else, and then set that into port B. Loop back and do it again. Let's go into Zen mode and see what's happening. Well, in Zen mode, we've got the camera. It's just programming it up. It's just doing its funky stuff. It's done. Oh, it's already started. A bit quick for me. Take my screwdriver, rotate the pot, and that will increase that delay to 1023 milliseconds, which is just over a second. If I bring it back, the LED will get faster and faster and faster. Look at that. Until it becomes 0, and then, because it's gone to 0, the wait is invalid. Hence, I put that little bit of code in there. If ADC is greater than 0, then wait. It needs to have a value, otherwise it's not actually there. But the better way to do this is to use this scale command. Now, you can make comments. Anything in red is like a comment with an exclamation mark, and it's really useful because you can do things like this. Like you can go comment and a question mark, and it will go blue. Exclamation mark goes red, and there's many of those. You can look in the help to figure those out. So what I'm going to do is take my ADC value here, and I'm going to use the function scale. It comes in with the range of 0 to 123, 1023, and I'm going to have the range of 30 milliseconds to 500 milliseconds. So we can play with what this LED looks like when it goes to the lower values. And I've chosen 30 milliseconds because of the camera will show you the difference. You might want it to be 1 millisecond, at least then the wait would work properly. It's not the wait, it's actually and there we go, it's doing it. Now the pot is actually returning 0 and it's been scaled to 30 milliseconds. Then as I rotate full on, it goes to half a second. Look at that. So simple. Seriously simple. So if you wanted to not use the scale, you could actually look at using this here, which would be if the ADC value is greater than a value of maybe 10, then you might do it that way. But there's two ways of doing things in here. There's always two ways of doing everything. So that's what I wanted to have a look at and show you the basics of how to do that type of rotate operation. I'm just going to look at something else to start with. I asked my favorite AI engine to write me a piece of program to do the same. It actually was 99% there. 99% there. I asked it to program the ADC, calculate a proportional delay, and set the LEDs. Okay. Let's look at what it got right. Well, it got right all this. All the left-hand side here down to here is absolutely spot on. Perfect. Do loop, perfect. Wait, perfect. How did it come up with this? Well, it says here, take the AD value, and somehow it knew to do the word, which I didn't tell it to do that. So that's fantastic. It knew it was a 10-bit read. We'll come on to that little error in there. And then it took the delay value and scaled it here. And it scaled it between 1000 and 1023 to 0 to 1 second. Fantastic. Don't know why I didn't ask it to do that, but it did it. And then it set the LED. It's not a rotate. What this did, it set the top 4 bits of the lower 4 bits of the value returned. It's not what I did. It's not a rotate. It's similar, but it's not a rotate. And there was one error in it here. That's a. You can't see it. Or can you? Ah, of course you can. Here, this should have been read AD10. I ought to teach it that part, I guess. But not bad. Good attempt, Microsoft. Anyway, where are we going to next time? We're going to be using an input switch to set the state of the LEDs. That's fantastic. We'll do that in the next video. We'll get to it. And with that, we'll call it a wrap. Enjoy.